Hello everyone and welcome back to Post Network Academy. I am Bindeshwar and in this video we will be breaking down one of the most important concepts in deep learning, Softmax, Cross-Entropy, chain rule and backpropagation. And by the end of this video you will understand how predictions are generated in a neural network, how we calculate the loss, and most importantly, how backpropagation updates the weights step by step. So without further delay, let's get started. So here we have a neural network and the structure is given here. We have three inputs, x1, x2 and x3. One hidden layer having two neurons and output layer which has also two neurons, and at output layer softmax activation function is applied, and thereafter we have used cross entropy loss function, and that would be used to measure the difference between predicted output y hat and target levels y. So without further delay, let's start. So here we will first of all going to perform forward propagation, and for a forward propagation we will require weights and inputs. So inputs x1 is 1, x2 is 2, x3 is -1, and these are 6 weights at input to hidden layer. Now here you can see that we will calculate Z1. So for a Z1 you will see that X1 weight, W1 weight, W2 weight and W3 weights are here, and one bias. So we will multiply inputs to weights and we will add a bias, and thereafter we will calculate, and that value is minus 0.3. The same way we will calculate Z2 and that is 0. After that we will apply activation functions. So here see that here is the activation function, and that activation function is sigmoid activation function, and sigmoid activation function basically 1 upon 1 plus e raised minus x, and that will value from 0 to 1. So here a1 and a2 both are sigmoid activated output at hidden layer. Now see that arrow has gone here, so Z3 will calculate and Z4 we will calculate, and we will be using A1 and A2 as input, and these are weights. So output of hidden layers have become input for output layer. Next layer you can say that. Now here W7, these random weights we have taken and one bias. See that Z3 W7 into A1, here W7 that would be multiplied by A1, and W9 by A2, so A2 W9, and those will be used for computing Z3, and the same way Z4, and we will get these values. So these are the raw scores Z3 and Z4. Now we'll use softmax, and what does softmax activation function do? It converts raw scores into probability vector. So here we will add all raw scores having e raise z3, like we will use exponential function, and thereafter we will add all of them, all outputs, and thereafter against one output, and that would be probability for class 1, and that would be for class 2. If there are 3, so the same way we will calculate also y3, and if you add them, so almost it will come equivalently 1.0, not exact 1.0, but it will come 3 classes, so probability will get divided. For simplicity, I have taken only 2 classes, but procedure is same if you take 3 or 4 or 5. Now here we will calculate loss function. So loss function is defined as here, that is cross entropy. So 2 classes, so 1 to 2, 3, so 1 to 3, so y1 log y1 hat. So, and what is the target? Target is very important. This one is the target. That's why I have written 10. So target is 10. That means y1 is 1 and y2 is 0. And we will plug these values. So this part will be 0 because y2 is 0. And this part 1 into log what we have calculated y1 at 0.561. And we will get this loss. Now we have get the value of L, that is loss. That means our network is not predicting correctly. So we have to adjust the weights. So how will you adjust the weight? First of all, you have to get gradient of the loss with respect to W7, the same way W8, W9 and W10. And for this one you have to find that loss is a function of y1 hat. Here loss is a function of y1 hat. Why we are getting this chain? Because we cannot differentiate loss function directly with respect to W7. So there is dependency. W deva L deva y1 hat. That means L is a function of the y1. Y1 is a function of Z3 and Z3 is a function of W7. So you can say that 3 chains here. So del L upon del y1 hat the same way. Now this part, if you differentiate, you will get this one, and this one I will explain in separate video, but this value would be this one. And here, because Z3 is W7 A1 plus W9 A2. So if you differentiate with respect to W7, so you will get this quantity. So if you plug, so finally you will get this one, and thereafter you will get this value. Finally W7, this one. So here we have already calculated. This one you can calculate because this one is we have calculated and this one is 1. So you can plug and we can get this value. The same way we can calculate gradient of loss with respect to W8, the same pattern you can calculate. Finally you will get del L upon del W8, this expression. Here you are getting A2 because here you will see that W8 Z3 were also computing using W8. That means here Z3 you are also computing here A1 W W7A1. Okay, let me write it again because weights would be written first. W7A1 plus W8A2. So if you differentiate with respect to W8, so this would be 0 and you will get A2. That's why the same way others you will get loss with respect to W9, you will get this one either in terms of Y1 or Y2, and W10 finally this one. Now how will you update? So the rule you will find out. This is the gradient descent algorithm. So you will update the rule like Wn, sorry, not Wn, W minus neta, that is the learning rate, and this between 0 to 1. Somewhere you will see that this is alpha, and update rules like this one. Here you can observe that this is the value of del L upon W7. So you will plug and you will update new weights. Also bias I haven't computed, but bias would be here, and here bias we haven't multiplied by any input, so you have not get A1 or A2. So this way you will update W7, W8, W9 and W10. So we have calculated from hidden to output. Now it's time to calculate loss, gradient loss with respect to input to hidden. So let's see that here. First of all, with respect to W1, so see that here, if you see here from, so L is function of A1. We'll expand this one, and A1 is a function of Z1 and Z1 is a function of W1. See that this one is okay, but this one we have to expand. So we can expand this one like del L upon del Z3 into Z3 del L Z3 upon del A1, sorry, A1 here. So see that here, this one we have expanded plus one more term, observe that here also, plus del L, because A here you can see that you have to add plus because 9 has also come here. So here del L upon del Z4 into del Z4 upon del okay A1. Now if you observe that this is y hat minus y1 and this one is y2 hat minus y2, and this one that is W7 and that is W9. So you can see that Z4 is also function of A1 and Z3 is also function of A1. So that's why we have to add. Both are function of A1 and both depends on A1. Z3 also and Z4. So we have to add. And finally we will get this one. And again this one is sigmoid function, and the derivative of sigmoid function, if you see that if there is sigmoid function 1 upon 1 e raised minus x, so its derivative would be sigma x 1 minus sigma x. We will explain in separate video, but here and here very simple, z1 is a function of w, so we will get x1. So this long chain you will get for a del L upon W1, and these values we have already computed, so we can plug them and we will get gradient of loss function with respect to W1. In the same way we will follow the same pattern and we will get for W2. You can see that the same pattern is here. The same way W3, the same way W4, W5. You can see that the same pattern. W5, W6, W7 for all. And the same way you will update the weights. I am not writing here. So this way you can understand loss function, cross entropy loss function, softmax, what are logics, how to calculate gradient of loss with respect to weights, and how you can update weights. Hope you understood, and for more videos and resources you can visit website www.postnetwork.co, YouTube channel, Facebook page, LinkedIn page, and also GitHub repositories. So hope you understood. Thanks for watching the video.